right, hello everyone. Quick check for the team that you can hear me.
We can hear you.
All right, you can see me fine as well.
Looks good to me.
All right, thank you. Well, hello everyone. Thank you for joining us today, and we're really excited to have you for our 4 ways to boost accuracy and efficiency for EM materials research. This is hosted by Media Cybernetics, and we definitely welcome you to enjoy the presentation today. And if you have any questions throughout, feel free to use the Teams chat. Put a question into that chat, and we'll do our best to get to that at the end of the meeting as well. But let's go ahead and start off with kicking it off right on time and talking about who we are. So first of all, I want to introduce myself. My name is Nick Beavers, CEO of Media Cybernetics. You're welcome to reach out to me afterward if you have any questions, or to connect with me on LinkedIn right there on the screen, /Nick Beavers. Joined today also by Tom Moyer, our sales manager, and Tom's email is there if you want to talk to him afterward as well. We're really excited to bring to you what we hope is a very useful topic, and that is, first, just a quick introduction of who we are in case you're not familiar. Secondly, talk a little bit about the platform that's going to enable the topics we're going to bring up today, and that is, what is the imagepro software platform? And then we're going to dive into the heart of our title today, which is the 4 ways to improve accuracy and efficiency in materials-based electron microscopy imaging. What I'm excited about is I'm going to do a quick overview for you, and then I'm going to hand it off to Tom for a live demonstration inside the software. And I really hope that that's going to help you understand the different ways we're going to present today that might help you in your laboratory for improving efficiency and accuracy. We'll go over the next steps as well afterward, and we'll end it with getting to all the questions that you may have throughout today's presentation. So thank you so much for joining, and this is the agenda we're going to follow, and let's dive right in with a quick introduction as to who Media Cybernetics is. If you're not familiar with Media Cybernetics, then I want to introduce you to kind of a refreshed company that is now focused on innovation. Media Cybernetics has a vision that we established a number of years ago, that is to advance innovation in partnership with the scientific community. And while a lot of companies definitely have very lofty visions and typically put them on a wall, we've ingrained this in every aspect of the organization. And we're very proud of this. And we want to really prove this by showing the scientific community what we can offer. We hope to be doing that here very shortly. We have a couple of big announcements where we're going to be partnering directly with universities in a partnership to bring to market a wonderful selection of improvements to efficiency in the lab, bringing great standardization and also a lot of really wonderful educational material in collaboration with these organizations. And we take this very seriously. So our goal with advancing innovation starts with the release that you're going to hear talked about today, where we brought the latest and greatest of AI deep learning to the fingertips in a very intuitive way. And we believe that each time we move forward, that is going to be our North Star of trying to create that type of innovation. Now, we hope to do this rapidly, and that's why the next part about who is Media Cybernetics, well, we're a company built for speed. We went private in 2020, and we have established no red tape policies in the company. And we have dedicated ourselves to removing anything that slows down development and that makes a closed ecosystem as well. One of our core values is that we want to have an open ecosystem, allowing us to work collaboratively with other software platforms, different types of microscopes, and not roping you into having yourself limited to anything really. But mostly we don't sell big microscope systems and try to create software that locks you into an ecosystem. Our goal is to make it so that your laboratory, using what we're developing, is very collaborative. Whether you're working on an optical microscope, an X-ray system, or an electron microscope, you could use a single analysis software that would work with everything. That would reduce your training time, that would reduce the the challenges and trying to constantly learn different techniques and different philosophies of how they approach the software. And so because of that, we're innovating. And what we're committing to is new technology launched annually. In last year, we actually launched around the June timeframe, imagepro 11.1, and we already are so excited for that annual release coming in the next couple of years. We're going to have one every single year that we're committing to. We are focused on lab efficiency, and that's the topic of today as well. And so because of that, I want to make sure that we're very clear in our communication every time that the reason we're doing this is going to be constantly trying to move forward that innovation. And one way of doing so is improving the efficiency. Another thing you may not know about us is that we've been around for quite a long time, and so we're a proven and trustworthy brand. While we're working on eliminating bottlenecks and improving our speed, which you don't see out of large kind of established companies all that much, we have the benefit of 43 years of experience since 1981, and we have over 150,000 publications. And we're very proud of working with the scientific community in this way. We love partnering in all these publications, and what you'll see is that we have the largest number of publications of any independent software company. So we're very proud of that. We're very humbled by the fact that we've been able to work with such wonderful people throughout the years to establish this kind of milestone. Just a little bit more about us, that we're based in Maryland in the United States, right between Washington, D.C. and the beautiful Chesapeake Bay. And we have a wonderful group here in our headquarters, but we also work all around the globe. And we have employees around the globe, and we also have a very large partner network. So no matter where you're located, we are able to get you in touch with somebody local. We have partners in every corner of the world so that you can work with Media Cybernetics and our products. And we have partners who are very well trained and capable that can really help to get you what you need. So with that in mind, if you'd like to learn a little bit more, please visit us at one of our online sites. We have our website at mediasci.com, our growing YouTube channel at Image Analysis. We just crossed a milestone of 20,000 subscribers. So if you haven't, go over to at Image Analysis and subscribe today. And also always posting on LinkedIn at Image Analysis as well. Feel free to follow us and check us out there. So that's who Media Cybernetics is in the shortest way possible. But what about imagepro? So the imagepro platform is an end-to-end solution. And so if you're not familiar with it, what you'll notice is I'm going to just break it down into 4 easy categories. We really work hard at trying to make sure we allow you to easily import from anywhere in any system. And we really pride ourselves on not associating ourselves directly with any one vendor. We have wonderful partnerships that we're very proud of, but overall, we're trying very hard to have import be very open. The ability to improve your images and process those, adjust them, and then of course, the core being the measurement and analysis and the analytics of imagepro, and then getting the data out to have a report that would allow you to actually use the data in a meaningful way. So a few quick examples to give you a sense of what it means to be end-to-end. So first of all, I do want to point out that while we are talking about EM materials today, the beauty of imagepro is that it is a very open application. And so we do work with over 150 digital cameras on the optical side. So if you are in a lab where you have optical microscopes, which most people do, then you could use the software both for optical microscopy and for electron microscopy. We support a lot of really wonderful brands, and if not working with the camera itself, we also support many file formats such as OME-TIFF, which is a wonderful open optical standard and allows a very easy kind of standardized way of sharing images. Now, when working with these images, you can do things such as live tiling, live EDF, HDR, time-lapse, many different types of things. And so just as a quick example, you could run a really nice high-resolution, fast tile in optical microscopy with many of these cameras. Pretty much any of them would work. And you could put together, without an automated system, a really nice mosaic. Now, moving on from the optical side to the electron microscopy side, obviously we're not going to be controlling the camera in the electron microscope. So for that reason, we've been working with different brands, and we have support for pretty much every electron microscope on the market. We've established a really wonderful relationship with Hitachi, and our friends over at Hitachi have put into place inside every Hitachi piece of software a send to imagepro button. So this really improves the efficiency. If you happen to have an Hitachi microscope, and depending upon the version and the year, because as they were putting these buttons in, they were in the more recent models, obviously. You may or may not have a send to imagepro button. Sometimes it's called the IPI button. And that would, if imagepro is installed locally, immediately transfer the image directly to the imagepro platform, really improving that efficiency. Now, beyond Hitachi and the wonderful partnership we have with that efficiency, really any of the other brands would work as well. And so if you're working with any of these brands you see on the screen, we support the file formats coming out of those, either from a proprietary standpoint, or if you save it out as a standardized TIFF, JPEG, PNG, whatever it may be. We support over 65 formats, allowing you to easily work with any of these electron microscopes and imagepro. So from a platform perspective, there's almost always a way to get images out into imagepro. Now, once the images are in imagepro, providing custom lookup tables, tiling, stitching, stack alignment, processing, HDR, improvements to the images, all that is possible. And just as a quick example, if you did have a where you're capturing a much larger field of view and you need to do some processing such as adjusting shading issues on the image on the left-hand side, one of the things we're doing in this image, just as an example, we're actually doing 3 different things. One, after the mosaic has been assembled and the overlap is established, we are correcting the shading in every single one of the frames. And then across the entire mosaic, there's actually shading from top left to bottom right that actually causes an imbalance in the intensity of the pixels at the bottom right versus the top. So across the entire mosaic, secondary shading correction, and then an enhancement of contrast. So you get a really nice image on the right-hand side, high resolution, and allows you to get that kind of detail where you can actually make proper measurements. On to the most powerful step where most people spend a lot of their time is the measure step. And so because of that, we have introduced in the latest 11.1, what today's topic you'll hear a lot about is beyond our machine learning segmentation, now a brand new AI deep learning. And of course, it's all the buzz these days. Everyone hears about deep learning. You hear about new ChatGPT functions and Microsoft's Copilot and all the different things that are really driving this revolution in deep learning and artificial intelligence. Now baked right into imagepro, a lot of great things that Tom's going to show you today live. I'm excited to show you. After you've done your initial segmentation, classification and phenotyping or identification in some way of what are the objects or areas you've identified and how do they relate and what are the measurements associated with them. And of course, some examples would be layer thickness as an example, easily identifying the layers, measuring the distance and average thickness across all of them. Some type of particle count where you're easily identifying every single individual particle. And then just a quick example on a life science side with really complex neuron where you're able to identify that, say, in a 3-dimensional stack, having used, I think this is serial block face imaging with Catan. And because of that, you're able to get wonderful reports, charts, graphs, stats, export, all of that able to be working with any statistical package that you'd like to, or just creating some kind of PDF with the report as well. Any way you want to see the data, any way you want to see the statistics, and also all the graphical capabilities for plotting your data available to you. So that really kind of gives you from a feature perspective, just an overview of the platform. So before we actually show it to you and give you a sense of it, I wanted to point out 2 quick things, which is that life science is possible at any scale in imagepro. And so again, if you're working in an environment like a core facility where materials is your focus, but there are life science applications at times that come across the lab, that would be possible with imagepro as well. So even though it's a very focused product on what it's capable of doing, we do work in both the life science and materials. So if you were working with life science, we would have from the low mag to the high mag, stained tissues and colonies, unlabeled cells, fluorescent labeled cells, and even the EM heavy metals, working on whole slide scans, bright field standard microscopes, a confocal microscope, and of course your SEM, TEM examples. Now, of course, we're talking about electron microscopy today, but if you are working with an electron microscope on both types of samples, you would have availability of, we'll bring this up throughout today just a little bit, just so that you understand the flexibility. On the materials side, again, magnification is really irrelevant for imagepro. On the low magnification side, if you're working with electronic components and need to be using, say, a stereoscope, or you're trying to do some kind of simple stitching of a scan, we can work at that magnification. Also, a standard reflected light microscope, phased or polarized. Material composition analysis in a wide field or even an X-ray system. And then, of course, as we're talking, again, mostly focused on today, microstructure and an electron microscope. And we're working with both SEM and TEM, focused ion beams, serial block face. All of those would be available to work with low to high magnification. So after that overview, let me tee up for Tom what he's going to go over and demonstrate to you in the software live, which I'm excited to show you. First of all, we really wanted to bring today what our focus of the last release of imagepro 11.1 was, and that was accuracy and efficiency. We've broken this into 4 categories. With the first 2, I'm going to talk about right away, and that is, number 1, a way that you could work with pretty much any software platform, but we're of course going to show you the imagepro platform today. But what we'd like to say is that older techniques of hand drawing or machine learning based segmentation methods for finding objects, areas, layers, fibers, you name it, they're pretty time consuming. And so with the revolution of AI and deep learning, our recommendation and what we've found after working with customers day after day is that starting with a pre-trained AI model is really a huge benefit in efficiency. And we're going to talk about what a pre-trained model is today a little bit, but this is really where we see things going into the future, where more and more software platforms and technologies will utilize a model that has some understanding of the ground truth information. And you're going to choose from, as we move forward, some type of starting point that already has knowledge. And this really improves your time and at trying to get a start. We find that pre-trained models can take anywhere from minutes, hours, days, or weeks to train. So it all depends on the complexity and how much it knows of your sample. But starting with that is a huge efficiency boost. And secondly, once you're there, it isn't always perfect. And so because of that, our second recommendation is that fine-tuning a model is a much better way of going about working with your images than it is starting from scratch every single time. So if you start with number 1 and then you establish that pre-trained model and then fine-tune the model, then you can save and share it and start to build your own internal database within your organization, your company, your lab, and you can actually create a really nice library that saves you time by having that starting point for identifying things. So let me show you a little bit about what I mean. Obviously, today we're going to be using imagepro AI, and we're doing the demonstration with the latest of that version so that I can tee up and help you understand how some of these benefits could be available to you. In imagepro AI, what we introduced was a brand new thing we call the neural engine, and it's what makes it possible to do what I'm going to show you. And the neural engine is kind of a unique thing. It's a translation layer that we created that enables deep learning architectures to work with one single interface that you can run a workflow through, and you can establish kind of a cadence of how you work with imagepro and the software in the workflow, but you're not limited to any one particular architecture. That's really the value here. So you might have heard of different deep learning architectures such as UNet. UNet's kind of a universal approach to deep learning training. We've created an image for our own custom, what we call base UNet. We've also introduced StarDisk, which is a very popular architecture. And then one of the most powerful architectures that is currently available, CellPose. It's a really wonderful model architecture, and it's amazing what it's able to do. But these 3 combined, plus the beauty of the neural engine, meaning that we're not limited to these 3, but we can easily add a 4th, a 5th, a 6th, whatever is necessary. And you'll only ever have to work with one interface. May have a few different options, but you'll only have one interface despite what's under the hood. Now, the benefit of the neural engine and this approach to it is that it's secure and confidential. First of all, it's all on-prem. It's on the machine that you're working on. And personally, we're not really that thrilled with a lot of the approaches today where you see people having to require you to upload your images. That takes a long time. You're having to give your intellectual property over to some company. We're not asking for your images. We don't really support that too much. We understand why that might be valuable in some ways, but they're also taking your training and then making it available to others. User-friendly operation, of course, that's paramount. You're not efficient unless you have user-friendly operation. Superior outline accuracy, which I'll demonstrate in a minute, and then protocol ready, which will tee up the next couple points. All of these are available in the benefits of the neural engine. Now, what they enable is what I'm about to show you here. When it comes to AI deep learning and kind of creating your segmentation outlines, whether that's large areas or a particular type of material or objects, there is a scale of difficulty. And if you're really familiar with AI, you'll know what I'm talking about here. And if not, be prepared that when you do enter the world of AI deep learning, you're going to come across these very quickly. And the first one is the most challenging, time consuming is starting with training. That means it has no knowledge of where your images came from, what they are, and what ground truth is. And so starting from scratch takes a long time. Then there's this idea of model zoos, where you have these large repositories of models that are online. It's wonderful. We love working with them, and we love what they're doing there. But that is challenging, trying to find the proper model and import it and work with it. Then, of course, there's using a model that has some kind of knowledge and fine-tuning it. And that fine-tuning can be a huge time savings. So it's a little bit less difficult because you're starting with something. And then the least effort and the most time efficient is going to be predicting with a pre-trained model that has lots of knowledge of something that looks very similar to what you're working with. Now, on this scale of the most difficult to the least, what we've done in our approach was to do all four. We decided that we wanted to give everyone the flexibility of starting from scratch with training, despite it taking a long time, or being able to use pre-trained models. And we would recommend pre-trained models. We think it's the most efficient. And so for that reason, what we've done is we've produced our own pre-trained models. And this is a growing library. It is kind of a moving list, and we're excited to be working with a lot of other partners to continuously create more pre-trained models. But from the life sciences side, again, if you're working with these, great, and if not, just hang in a second. We've supported a number of different types of images and the material in the image. So pre-trained models for fluorescent cells and dendrites, nuclei, stained tissue nuclei, label-free cell and nuclei, blood vessels, and of course in electron microscopy, working with a lot of very complex life science images, trying to find things such as mitochondria and nuclei. And a lot of the times these life science images are substantially more complex than a material image. So it's always great to kind of see what's possible on the life science side, so that when you do move over to our pre-trained models, and we currently, in this current version of 11.1, have 5 pre-trained models, but I have a little bit of a teaser for you today to actually make that 7, and that is we're starting with titanium grain size, titanium alpha phase grain size. We have a really nice versatile model for grain, particle size analysis in a versatile way, kind of working across many different types of particles and what they like. One that's a bit of an odd but really interesting model that's called Widmanstatin, that is finding patterns and striations in different types of a look and feel. Not very blob-like, but more pattern. And it's incredible how much of an accurate identification the model will do. And then 2 teasers, which are coming in our latest patch, coming out very soon. Within the next month, we're going to have electrospun fibers and ceramic glass fibers as pre-trained models that has seen many, many different images, and we have pre-trained it ourselves with a lot of ground truth data, enabling you to have a head start when you're doing your analysis. All these are applicable for today and are available with those 2 coming soon, but the 5 above available right now. Now, if you start with one of these pre-trained models, one of the benefits of it, as I've mentioned, is accuracy. Tom's going to demonstrate that in just a minute. But what I wanted to do is just give you a quick example. I mentioned life science can have very difficult looking images. And so it really makes it, when you see this, you'll understand why on the material side, it sometimes is way easier to work with. Let's give an example of a machine learning based approach to something that looks like this, right? You have kind of low contrast, you have a really challenging image where we're looking for mitochondria. And the mitochondria are these very oddly shaped circular or non-circular patterns that are in this image with a bit of a zebra stripe in them, if you will. not being very technical, but just trying to give you a sense of what you're looking for. And you can tell it's actually found a lot of the chromatin in the nucleus. That's not what they were looking for. And this one is just completely wrong. If you provide some ground truth data to help the model understand what it's looking for and what does a mitochondria look like in an example where it's very low contrast, even if your eye can't pick it up, you can get a result like this. And we've worked with a lot of customers who, regardless of the sample, the AI deep learning model is just undeniably more accurate and does so in way less time than it would take to do multiple filters, try to find edge detection, or even mark this up by hand. So again, talking about accuracy and efficiency today, just using deep learning in general will improve your efficiency and accuracy without anything else we're talking about today. This is really a huge benefit, and we wanted to encourage you, if you haven't really taken a look at that yet for your lab, we highly recommend it. Whether you use imagepro or not, it's definitely the way to go. Okay, so once you've used a pre-trained model, I wanted to mention number two, and number two is fine-tuning. The definition of fine-tuning is simply that you would start with a pre-trained model like the ones I've mentioned just a moment ago. However, they don't always accurately find everything you're looking for. They may miss an object or two. And so because of that, you can see here in this example, I missed 3 objects. All I need to do is identify what those objects are, label them really quickly, feed that back in and retrain the model, and then rerun it, and it will find everything. That's all fine-tuning really is. It's basically letting the model know what it missed, and then it will really take that into account the next time it sees a next image. Okay, so moving on to my last 2, and then I'm going to hand it off for a live demo. Streamline steps with a protocol. Now, we call ours protocols, but if you work with other software, it might be called pipelines, might be called recipes, or whatever they may be. But streamlining your workflow in analysis is definitely a great way to improve the efficiency. And then if you follow that up with number 4, batch processing. Now, everybody's heard about batch processing, but what I wanted to point out that's unique about this is if you take number 3 and establish your steps, that includes an AI deep learning model, and it is fully self-contained so that you don't have to have any interaction with it, then number 4 can be an automated batch process that can then be combined with data output in something like a custom report. And maybe your report's not what you need, but you could either have data export or a custom report, and that would allow you to really improve the throughput in your lab, and some of the things we're going to show you today in the live demo as well. But generally, to accomplish this, the way we talk about these at Media Cybernetics is what we call analysis protocols. And the analysis protocols is combining 3 steps. We combine the segmentation step, which is the identification of the blob-like object or the area of interest, then some type of classification telling you, large particles versus small, or these types of fibers versus those, or backgrounds or voids. And then lastly, taking that data and then turning it into one number or a series of numbers that would allow you to understand what it is you're trying to achieve in the experiment or the quality assurance test. So these are the steps that are combined in an analysis protocol, making it a lot easier to automate those without having to do them manually. It's a standardized workflow. And so you get guided steps, you get AI integration, instant reports, and it's batch ready. And with all these things, our recommendation would be, whether you use a protocol or not, look for something that would allow you to automate this in a way where anyone using the software can then, from one user to the next, have the same guided steps, the same models that have been established for the lab, the same standardized template reports, and of course, being able to kind of remove that human step where you're having to make a judgment call as to whether a particle or a fiber should be counted or not. When you batch process, you're establishing your rules up front, and you're eliminating the human bias by having to do it in an automated way. And at least it's consistent from one image to the next. So these types of things will help your standardized workflow, help you be a little more efficient. And it's just our experience after working with customers day in and day out who are looking for these types of answers. Again, what we've done is, instead of making so every time you have to build a protocol, you have to build it yourself, we've actually tried to make the process a little bit easier by creating a handful of tailored protocols. So right now, imagepro 11.1 has our nuclei, mitochondria, nuclei, chromatin, and mitochondria on the life science side, again, in case that's something you're doing. And on the materials side, what Tom's going to be showing you today, Fiber separation, some really impressive results there. Composite materials, grain size, fiber thickness. We also have layers analysis, phase analysis, particle phase, a very robust particle size analysis, pores, and even patterns. And so all these are available where both the workflow, so it's the end-to-end workflow, including in the protocol an AI model, let's say, that at the particular step for segmentation automatically calls it and works with it, and makes that whole process faster. So that's my quick overview of the 4 things that we think will make it actually more efficient and more accurate in your lab. But don't take my word for it. I wanted to actually let you see a live demo, so I'm going to pass it over to Tom and allow him to show you in real time what it looks like in the new imagepro. So Tom?
Thank you, Nick. All right, so let's dive in. Today, I'm going to cover what Nick has mentioned previously. AI deep learning segmentation, our latest feature with version 11.1, how we've implemented that. So we'll take a look at how we've implemented it, how we can segment objects, find patterns within images by using a pre-trained model, or cloning and fine-tuning a pre-trained model, or creating a model from scratch. And then we'll tie everything together with the protocol collections and coming up with a completely automated workflow for analysis. All right, so diving in, let's take a look at how we've implemented AI deep learning. So again, AI is just a segmentation method. Previous to this, we had histogram-based segmentation or manual segmentation, as well as machine learning, which we call smart segmentation. With AI deep learning, we have 3 different panels that are available. We have our prediction panel, and this is where we can take any pre-trained, cloned, or model that we've created from scratch and apply it to an image to see how well it does with the segmentation. We also have our training panel. This is where we can either clone a pre-trained model or we can train a model from scratch. And lastly, we have managed models, which is our model library. So if I open up Model Manager, you'll see I've got a collection highlighted now. These are all of the pre-trained models that are available. We have the 2 brand new ones, the electrospun fibers, as well as the ceramic and glass fibers. We have some very general models, such as this general objects, TEM, mitochondria, nuclei. I can also go into any collection if I want to highlight the life science specific models, materials models, or I can go to my models. And these are any models that I've cloned and I've fine-tuned them, or models that I've created from scratch. So you'll also notice within Model Manager, I can open any of these models into the prediction panel and apply them to an image. If I've cloned a model, I can do some additional training. Again, you can also import models into imagepro. You can also export models and share them with other imagepro users. So in the background, I have this electrospun fiber image open. So all I have to do to test one of the pre-trained models is to highlight the model that I'm interested in and then open it up in the prediction panel. So there's just a few settings that I can change within the prediction panel. First, I have configure classes. So this is where I can give a name to the class. This is already set to fibers. I can also change the overlays. I have this set to random to make it a little bit easier to see the separation between fibers. Next, we have an option to set the object diameter. So this particular model, again, we have 3 different architectures that we work with: base, UNet, Stardust, and CellPose. Depending on the model's architecture, the prediction panel can look a little bit different, but for Stardust and CellPose, we have to set an estimated object diameter size. We also have the option to change strictness percentage or probability threshold. This will essentially open up the model to find more objects or less objects. Once I have these settings configured correctly, I just click on count. It will go ahead and run that model on the image and show me the overlays in terms of segmentation. And you can see this pre-trained model has done a great job of segmenting the individual fibers. So if we look at a few other examples, let's take a look at our general objects model. So this model has been trained on a lot of different objects. You can see we have coffee beans. It's been trained with soccer balls, some optical microscopy images, some EM images. It's a very broad model that can be applied to find any sort of blob-like objects within an image. So once I have these parameters set correctly, again, I'm just going to click on count and see how well the model does at segmenting the objects. This is based on the cell pose architecture, which does a great job of overcoming any sort of shadows or complex features within an image, and does a great job of segmenting the individual objects. So for my last example, let's go ahead and open this very unique model called Widman-Staton patterns. This is based on our base UNet architecture, which is really good at finding complex or unique patterns or areas within an image. So you can see this prediction panel is a little bit different because it is a pixel classifier. We don't have to set an estimated object diameter. So I'm just going to click on count, and we're looking for these striations in the left and right side of the image. So without doing any sort of pre-filtering or pre-processing or filtering after the count, it's done a great job of finding these extremely unique patterns, which again, if I zoom in, you can see that these striations in terms of grayscale values match some of the other objects in the background that I may not be necessarily interested in. So Nick went through machine learning versus AI deep learning from an accuracy standpoint. So one thing that I'd like to do very quickly is just get rid of these other images. Let's open another cloned image side by side and try to apply machine learning to the same image so we can highlight how accurate AI deep learning is. So I'll go ahead and put these images side by side. And now I will open up machine learning. And so with machine learning, I'm just going to highlight the objects that I'm interested in. So a few areas for the Widman-Staton pattern, and then I'll just highlight the background. And I start to get an overlay in real time, which I can fine tune. I can try to get rid of some of these single pixel overlays in the background. I've worked with this image enough to know that this is probably as good as it will get with machine learning. And then I can apply the count. So you can see it's picked up a lot of the smaller objects in the background. Although it's highlighted some of the Widman-Staton pattern, it is not nearly as accurate as using an AI model to find these very unique and complex areas. Not to mention, if I do come up with a machine learning recipe on this image, and I have any variation in the next image, my machine learning recipe may not work, whereas AI deep learning is able to overcome any variations between, or most variations between images. All right, so let's go ahead and open up an EM image. I have a sequence here. So this is an image sequence that we has not been used to train an AI model before. So none of our pre-trained models have seen this image. And you can see as I move through the sequence, I have 8 individual images. And it starts with an image that just has particles. And as we move through the image, we start to see some of this debris in the background. So the approach, again, is going to be to start with a pre-trained model. So let's go ahead and open up our model library. And I'm going to scroll down to our versatile particles model. So this is the most appropriate model that I can use to test on this image. So we'll go ahead and open this in the prediction panel. Again, I'll just make sure that I have my classes configured correctly. I can run an automatic object diameter estimation. So again, this is based on CellPose. This is a feature that we've implemented into the CellPose architecture, where it will go through the image before we actually apply the model and come up with an estimated object diameter. And now I'll just click on count. And you can see it's done a great job of finding all of these particles. But what happens when I get towards the end of this image sequence and I start to see some of this debris in the background? So this model is picking up some of the debris. Although it's doing a great job of finding the particles, it needs some additional training to ignore the debris. So this is where we talk about fine-tuning, cloning and fine-tuning a pre-trained model. And it's very easy to do. All I have to do is click on Clone Model. I will give this a new model name, so I'll say New Particle Model. And I'll click on OK. So now a new panel opens up. This is our training panel. And the first thing that I'm going to do is change the class color, and I'll also increase the line width here just so it's a little bit easier to see the objects or the overlays. So within the training panel, all I have to do, because it's done a great job of finding all of the particles that I'm interested in, with this particular example, I would just need to delete some of the labels over top of the debris that I'm looking to get rid of. If I need to add additional objects, I can use a number of tools that we've implemented. One is our paintbrush. And the paintbrush does a great job, the default brush. If I draw a new object and click enter, you can see that it hasn't merged those two labels together. We also have the option to enable merge and edit, which would now allow me to draw another label that intersects with an existing object, and it will now merge those areas together. So it's very easy to add labels, to delete some of the predictions where I'm looking to train it to ignore those areas. And we've also implemented a region of interest tool. And this is very important. With this particular image, it would not take long to delete all of the incorrect labels. But let's say I had an image with thousands of objects. I don't necessarily want to label all of the objects within the image. So we do allow you to draw a region of interest or multiple regions of interest, and then you only need to label what's inside of those regions. So to speed up this process, I have already come up with the correct labels. So I'll just go ahead and apply them to this image. So you can see I have 125 labels. And now I can just add this into my training set. So those have been added. Before I train a model, if I want to, I could move to another image within the sequence. I could open up a separate image or draw another region of interest. But we found that usually we just need to give a little bit of additional training and the model will quickly train itself to identify the correct objects. So now I'll just click on train. So with the CellPose architecture, you can see I'll have a brand new model that I can test out in under 30 seconds. So it happens very quickly. Again, this is all happening on my PC. Nothing is uploaded to a cloud. So there is no time in between fine-tuning and testing out a new model. Great, so now that that is trained, let's go ahead and open this up in our prediction panel. And I will go ahead and click on count, and we'll see how well this new model does at finding objects. And you can see it has not found any of the debris in the background, but the model was also trained on this image. So let's go ahead and move to another portion, and we'll click on count. So I can see it's still doing a great job. It's only finding the powder particles, and it's not highlighting any of the debris. So that's how simple it is to apply a pre-trained model, or if you need to, you can clone a pre-trained model and do some fine-tuning or additional training. And now I have a brand new model that's unique to my images that I can now use within a protocol. In some cases, if you have a very unique pattern or a very unique object that you need to highlight, you may need to create a model from scratch, which is perfectly fine. All we have to do is go into our model manager, click on new, give it a name, set some certain parameters. It will open up in the prediction panel. You follow the same exact steps, train the model, and then test it out in the prediction panel. So now that I have a model that's working very well on my images, we want to tie everything together in a nice streamlined workflow. So this is where we have implemented our protocols. And again, we have some very general protocols: object count objects within objects, and a percent area measurement protocol. Or we can go through the different collections, be it life science, we have optical as well as EM, or materials. So for this particular analysis, I'm going to be using our particle size analysis protocol. So to open up a protocol, all I have to do is click on the version. So I'll go with the AI powered, since we want to use the model that we just fine-tuned, and I'll click on load. So by default, we are in interactive mode, and you can see I only have 2 steps and then a results step. So protocols give you a guided workflow. It's very easy to change certain parameters and follow the steps to come up with your own unique protocol with your settings. So the first thing that I'll do is, if I need to, I can change this class name, but it's set to particles, so that's perfectly fine. If you're working with color images, this dropdown would show red, green, blue color, but because we're working with EM images, we only have a monochrome. I can also associate a calibration file if I need to, or I can draw a region of interest. If you do have a scale bar in the bottom of the EM image, we can draw a region of interest. Although with AI deep learning, because we're training on the entire image, if we're not highlighting the scale bar, the AI model will ignore anything within the scale bar region. So it's not necessary to add a region of interest when you're utilizing AI deep learning. All right, so if I click on next step, with this particular protocol, it's asking me to point to an AI deep learning model. By default, it's going to general objects, but I can just go into my models and I'll click on the new particle model that we just created. Again, I'll follow that same workflow. I can change settings. I'll run the automatic object diameter estimation, and I'll click on count just to verify that everything's working correctly, and click on OK. So now you can see I've got all of my objects highlighted in blue, and within this panel there's a few things that I can change. If I need to set a threshold, and this can be based on any measurement type, whether it's area, we do have intensity, diameter. If I need to gate things out based on ranges, I can do it here. We also have clean borders set to all. So with clean borders, it's going to ignore any particles that are cut in half because they're touching the perimeter or the border of the image. I can also apply a split, but again, with AI deep learning, most of the time we don't need to apply a split. It does a great job of finding the individual objects. Lastly, I'm going to classify these particles. So we do have a learning classification where you can combine measurement types and create different classes and basically train on those different classes. But for this example, we'll just go off of a single measurement type. and I am going to use area as my classifier. So I'll set 12 different ranges. I can give each of these ranges a name, so I can say 0 to 10 microns, 10 to 20 microns. I can also manually change the ranges or the bins as well. Once it's applied, you can see it's now changed the colors based on the classes, and I'll just click apply, so this all of this information will now stick within this protocol. So finally, I'm at the results step. Again, with this protocol, we have highlighted some statistical information, such as the total objects count, D10, D50, D90 numbers, and some other various statistical information. We also have individual measurements, so if I'd like to look at some of the individual measurements, I can do that, or class statistics. Any of this data can be changed. If I go into define measurement types, if I need to add a certain measurement type, I can do it here. I can also generate a report. So we have pre-configured reports available. If I go into my report menu, you can see for each and every protocol, we have multiple sites report. So this can be used if we're batch processing. It includes some additional graphs, or we can do it for a single site. So if we're only doing analysis on single images, one at a time, we've given you the option for both. So now that I've configured my protocol, I have all of the parameters set correctly. I want to automate this process. I want a single button click so I can open up my images, batch process, and get my results. So before I save a version of this, I'm going to click on Auto Create Report. I want to automatically create the particle size multiple site report, and we can automatically export these results to Excel. So now I'll save a version of this, and we'll call this New Particle Protocol, and I'll click Save. Perfect. So now we're back at the initial step, and I'm just going to clear out all of the data that we acquired while setting up the protocol. And now what I can do is take this out of interactive mode. And as soon as I do that, you'll notice that instead of being guided next step through the various steps, I have this option to run selected. So I can either run this entire process with a single button click on a single image, or if I click on the drop-down, I can click on Run Batch. And so this is where I can batch process an entire folder full of images and extract the data from all of those images. Because I have this image open in a sequence, if I click on Run Selected, it will actually process each image within the sequence. So we have a progress bar at the bottom showing us the progress. Again, it's going to analyze all of these images, and it didn't give me enough time to recap. It happened very quickly. So now I can look at all of the images in my data collector. I have a snapshot showing the labels, all of the statistical information, and again, all of the individual measurements as well. I set the protocol up to automatically generate a report. So here we can see the multiple site report. I've got all of my high-level information as well as those snapshots. That all happened with a single button click. It's also exported all of my results to an Excel spreadsheet. Again, I can alter this, how I want the data extracted and compiled. Everything is completely customizable. And lastly, I just want to highlight a very popular application right now, and that would be battery analysis. So we've had a lot of requests for battery analysis, and I have a protocol that I've created based on this particle size analysis to run a battery analysis. So here you can see we have a cross section of a battery. I have altered the standard particle size protocol to include a battery section, which would be the overall area. I've got particles set as a certain class, and then a middle layer as well. So all of these utilize a different AI model. Some are just the standard pre-trained, some have been cloned. And if I take this out of interactive mode, I'll just go ahead and run selected to go through that process with a single button click. I've also generated a custom report. It's very easy to change reports. You can add your company logo, certain specific information within the report. That way it's completely repeatable and customized for your specific application. So now it's running through the various AI models. Again, this is utilizing 3 different models. I've got one that's highlighting the entire area, one that's finding the particles, and then one that is highlighting the layers. And you can see I've generated a customized report, everything with a single button click. So that's the process from start to finish, and most applications follow this exact sequence. We're going to apply one of the pre-trained models, see how well it does. We can, of course, clone and fine-tune a model, and then we can easily incorporate that into one of our protocols, which again can be customized for your specific needs. So that's the demonstration. I hope you gained some value from this and a good understanding of how we've implemented these new features into imagepro to automate your workflow.
Great. Thank you, Tom. Well, that's really useful to have that live demo so that way you understand exactly what it is that we're speaking of from the overview. Now I just want to really quickly bring your attention to some next steps. So first of all, if you were considering the need for something that would be more efficient, more accurate, obviously in today's webinar, we want to just bring to your attention 4 ways that we think would be really useful to you. If you already have software that you're maybe not utilizing AI or not utilizing some kind of pipeline, obviously we'd encourage you to go take a look at that so you can improve the efficiency of your lab. In terms of if you don't have some kind of solution for that and you were looking for something, imagepro is a unique product in that it provides everything we've talked about today, from the superior outline accuracy, a user-friendly operation, no uploading with only secure and confidential analysis. It is protocol ready. It provides those guided steps to make things really easy and standardized. Fully AI integrated so that you have all that capability right at your fingertips, the batch processing ready that you saw Tom perform, and of course the ability to create instant reports from any type of analysis process. So next steps, if you're interested, there are packages available. There is an imagepro AI for life science package that includes everything we talked about today and showed you, and then a corresponding imagepro AI for materials package as well. Both of these would give you all of the pre-trained models for materials or life science, all of the protocols that we talked about, and the ability to do the automation that we've really put a focus on today. But also, if you do need to do one image at a time, draw manual lines or do some kind of really non-automated task, that's also available to you, but definitely just not the most efficient process. Now, obviously, with any software, there's a learning curve, and so if you're not familiar with imagepro, one of the things we would recommend is our brand new success plans. We're offering that in 3 different tiers. Standard, where you get a really nice onboarding to kind of get you started on the product with an entire year of technical support access. We also offer a professional plan where you get everything in standard plus the annual upgrade protection, allowing you to have the latest and greatest every single year, which we are promising and definitely delivering on. The last few years we have delivered on this and are going to continue into the future. And also our brand new protocol and model pass, where throughout the year we're releasing new protocols and models and making them immediately available to you instead of you having to wait to purchase those models in a future upgrade. And then lastly, everything in standard plus professional gets you the ultimate package, which allows uptime guarantee. So if you need more licenses over time because your needs are changing, we actually supply a handful of licenses to you to be able to have continuous uptime. Also, if IT needs to take down your licenses for whatever reason, and actually, let's say you have a network license in imagepro and you have multiple licenses connected, we do see that sometimes they'll restart and recreate servers. will provide licenses so that you never have downtime if they're doing that. License server support, again, that is available to connect multiple imagepros and to provide an access for floating licenses over a larger facility. Software training hours, application service, and even model training as a service as an option to replace some of your hours with that instead. So a really nice solution with the Ultimate to make sure that you have the best possible success with imagepro and the work that you're trying to do. So with all of that, you can get these types of plans in 1 or 3 year increments. It's live, remote support and services, and it really helps to give everyone a peace of mind that the investment in this kind of solution is going to reap the benefits that you're hoping for. We provide the onboarding, the support. We make sure that it's not a salesperson really that's doing this, but we have our technical application people behind the scenes that are working with you. So you transition from sales to support. And then also new features annually, it's promised, in addition to your ability to schedule the training when it makes the most sense for you. And it's actually quite affordable. There's competitors on the market that are selling these types of services with even less features for over $10,000 a year. We find that not to be very affordable. Our goal is to make it accessible to you and to work with the community. So we're offering it at a substantially lesser price than that. And we'd encourage you to reach out to us so we can really help you to understand what something like this might be for you. And so hopefully this was helpful for you today. 4 ways to boost accuracy and efficiency. Hopefully we delivered on that promise with a focus on EM materials research. If you'd like to learn more, go to mediasci.com. And of course, if you have any questions, we'd be happy to take those now if you haven't already been putting them into the chat over time. So Tom and I will take a quick break, take a look at the chat. And if you do have questions, we'll hang around for a few minutes to go ahead and answer those. If you don't have any questions or aren't interested in hanging around for that, thanks so much today for joining us, and really hope you were able to learn something today, have some encouragement about what direction to go to boost accuracy and efficiency. And if you have questions, we'd love to hear from you, so please feel free to reach out. Thank you for your time today. Okay, so let's go ahead and stop sharing, and we will transition over to our Q&A and check to see if there's anything that has been put in here. And if not, we'll let you off the hook and just go ahead and wrap up today. So a really great question. Thank you so much for asking that. And I think that we have a good answer. So the question of, is there a model for detecting ferrite in a pearlitic microstructure in steel? And the answer is really close models that would allow you to get a good head start on that. I believe that both our a number of our different grain size models are aware enough of the ground truth of what is inside of that grain structure that it wouldn't probably take that much to provide a little bit of fine tuning to get exactly what you're looking for with the ferrite in the pearlitic microstructure. We've seen those types of images. We've worked with customers who have those, not specifically offering that exact model, but we've seen really good success with a starting point of one of the pre-trained. So it would be a quick transition for you. Okay, another minute here just for any questions that didn't come in yet. I don't think, Talia, do you have anything from your end?
I'm not seeing anything either.
Okay. Well, no problem. Thank you all so much for that today. If there are any other questions, feel free to reach out to us. We provide our emails and we gave our website. Any method you want to reach out would be great. Thank you for your time today. We'll go ahead and wrap up and say hopefully we'll see you on the next one. We're hoping to have a lot more webinars in the coming future. And if you would like to join those, feel free to do so. So have a wonderful day. Thank you.
Take care, everybody. Thank you.